Rational numbers are those numbers that can be divided with each other. Like we can say that 1 divided by 2 is actually a divisible number. And then we have 1 over 1 is equal to 1. This is actually like we are dividing 1 with 1. But when we talk about the set Q is equal to A over B, AB belongs to integers and B is not equal to 0, was named as the set of rational numbers. Then why it was named as the set of rational numbers? Because all those numbers which were actually plus minus 1 and plus minus 2 etc., this set of rational numbers which was actually denoted by capital Q was also actually had you may say that it actually had the set of divisible numbers as well. For example, if we say that 1 over 1 or 1 divided by 2, these kind of fractions, these are called fractions. It can be square root 1 over 2. These all fractions were actually included in this set of Q. Q is actually just set of rational number. This is just a symbol Q. It was just, I think, fixed by mathematicians. It was no basic logic. Notation or a symbol can be anything. Still, the solution of equations such as x square, now x raised to power 2 is equal to 2, or x raised to power means that x has a certain power which is actually written as 2. Like you may say that what is power, or x raised to power 2 means that if we have a variable x and if we write some number on the top of it at the top right corner as it is written as x, it can be x raised to power 2, it can be read as x raised to power 2, it can be read as x square. X square means 2, or x square is equal to a, where a is not a perfect square, was not possible in the set of rational numbers. Like what is a square? A square is actually something that, for example, if we say that we have a square shape, then it means that something which is actually it has all perfect sides, right? It has for example, if we talk about a square, it has 4 sides when we talk about in 2 dimensions. And 2 dimensions means if we look at from the front, then it will have 4 sides and it will have 4 perfect sides. But a square root is that, for example, if we cover it up with a perfect shape as well, but that cover should actually fit it means that, for example, if you say that I have placed some cookies in a jar and then cookies will fit in that jar, you can calculate the value of all those cookies, means that how much cookies are in there and how much they are worth. Like for example, if I place 10 cookies in a cylindrical jar, then that would mean I have actually placed 10 cookies which are actually of rupees, let's say 100. And then if I talk about that, if I will place a chair in a jar, so that is not possible, right? I cannot place a chair in a very small cookie jar. So this is just an example of why a certain number cannot be placed in the set of rational numbers. For example, it cannot be perfectly divided. This is actually the point. So the irrational numbers of the type plus minus under root 2 or plus minus under root a, this is actually under root a. Under root means the perfect number which cannot be actually divided, because numbers are always perfect. But if it is cannot be divided by any number, then it is placed under the square root symbol and placed in the set of irrational numbers, where a is not a perfect square, were introduced. This process of enlargement of the number system ultimately led to the set of real numbers. So it means that if we talk about that a chair cannot be fit in a cookie jar, then the chair has to be placed in some other room. So it means you will see that certain sets were also introduced as a new you may say that category. Like if I say that I cannot place a cookie jar in a smaller container, for if it is very smaller, like the size of a peanut. And if I say that I have a bigger car, and then definitely it has to be placed somewhat bigger than the cookie jar, right? it means different sets which can accommodate huge numbers, they were introduced. And that set was called real numbers, because real means it has real size. Like a car cannot fit in a cookie jar, so it means that a car is actually able to be fit in a room or a garage. So that is a real thing. So that is denoted by capital R. It is actually equal to Q union Q dash or Q prime, where Q prime is the set of irrational numbers, because Q is actually union. This symbol of U means union. Union means, for example, if I combine chocolate cookies with the lemon cookies and I also place them in the single jar, then that can be called as a whole set. Like I actually add salt and sugar and I sprinkle it in some recipe, then that will be called as a real combination. Or you may say that if I combine 2 sugar spoons and then I multiply it with some, you may say that price, then it will give me actually the price of 2 sugar spoons. Like I'm just trying to say that if we actually calculate bigger numbers like multiplication with addition or subtraction, then we can actually have a bigger set of numbers which is used most frequently in everyday life. Like this page is actually ending with the line that real numbers are actually those numbers which are actually used most frequently, means which are actually used very much in the daily life. Like we actually use we cannot say that we only use number 1 or we only use number 0 in a daily life. We actually use number 1 lakh or 1 trillion or 1 billion or even 2 billion, like it's like unending, right? So actually to accommodate all those unending numbers, we have used the set of real numbers. Then we have the very first example of our very first chapter of number systems. It is actually stating that point means decimal, and 0.25 is actually equal to 25 over 100. Like decimal is actually a dot or full stop in mathematics. It actually denotes 100, and it is a rational number. Rational number means that it is a fraction. Then 0.333 is actually equal to 1 over 3, is a recurring decimal. It is a rational number. Like one may question that how it is possible that 0.25 is actually 25 over 100 and 0.333 is actually 1 over 3, because the 100 is actually cancelled out with the numerator. Numerator means the number which is actually written on the top, and denominator means the number actually which is written at the bottom. Then 2.3 bar, actually that is written as, like if we talk about the number which has actually this symbol of bar or line, like we underline something, if we put that underline on the top of a number, then that actually becomes a unending number, for example, and it means that it is an unending sequence or continuous number, but that same number, not in any other. Like 2.3 bar would mean 2.333, so on means that unending series. It is also a rational number. Like I think this is the point that should be come into our mind while we read the definition of a rational number, that rational numbers are not those that are actually written in the form of only fraction. There can also be those numbers that are actually are in repeated stage. In repeated stage means like they can be written a lot of times. Then we have number 4th example of rational numbers, because we have just studied the definition of a rational number. So I think when you are attempting a paper, it is actually very wise, whenever a definition question comes, you should always write the heading of a rational number. For example, if it says that define rational number or explain a rational number, then you should always write the definition of a rational number, and then you should write the example as well. And the example can be anything, like as it is written 1 2 3 4, or like as it is explained. that these numbers are rational number, this is a rational number, you can write any good example, because it creates a good impression that you can actually explain something with the help of an example, and that actually explains that you have actually understood something. This kind of thing is actually going to take you to places of learning to a very great way. Then the fourth example is 0.142857 is equals to 1 over 7. You can actually use a scientific calculator. It is actually available in a very good you can say that bookshop or market. It is a rational number. Like if you divide 1 over 7 and the answer is 0.14 something, then it is a rational number.